completing the square to vertex, bless you, to vertex form is a little different than solving by completing the square because you have to keep everything on the same side. Okay? Bless you. So before we got x squares and x's together, and then we moved the thing on the other side, but the problem is we have to keep everything on the same side. So when I say like group the first two together, it's because we're used to just having x squared and x together. So what I'm going to do is I'm going to look at just that grouping together, and this part, which would normally have been moved to the other side, we just need to leave it alone for right now. Okay? Okay, so when you are solving, it always says, what's your a? So what is your a? 1. Okay, so then the first question was, is a positive 1? Yes. So I don't have to worry about that. I don't have to divide, which in this case we're going to have the factors. I'm good to go. So then it says that you're going to add a blank to both sides. But instead of adding a blank to both sides, because we're keeping everything on the same side, we add a blank on the inside, but on the outside, we have to subtract that number. Okay? So we add it on the inside, but to balance the equation, we subtract it. Because before we would add it to both sides, but since we're keeping everything on the same side, we add on the inside, subtract on the outside. Okay, what's your b? -5. So what do we do with b?
Divide by 2.
Okay, so we're going to divide b by 2, and then we're going to square it. Okay, so -5 divided by 2 is -5/2. If I square that, that becomes 25/4. So what do I do with that number? Put it in both my blanks. Okay. Then this now is a perfect square, just like before. It's going to be x plus, and then whatever my b/2 is. Well, my b/2 is -5/2. So this would be x minus 5/2. Okay, if you don't like 5/2, what could you do instead of 5/2? Because 5/2 is as a mixed number. 2.5. So if this makes you feel better, then write it like that. Okay. Now, what about the outside? What do you want to do with those numbers? Add them together, right? So I would take 6 minus 25/4. So this would be the same thing as 6 1/4, right? So this would be minus 1/4. Okay, I don't really care this way or the other way. That is writing the equation in vertex form. Be able to graph it. Okay, so this formula is that, which I know we've talked about it, okay? I'm sure it's not the first time. Okay, so what is a vertex of a graph, of a quadratic?
Where it starts.
Okay, it's like I call it the changing point, right? So like if this was this graph, it'd be right here, right? It was. Okay, so if I'm looking at a vertex form, my vertex is HK. Okay, what's your axis of symmetry? Okay, it's the line that cuts the graph in half. So this would be your axis of symmetry. Which if I'm doing it the same would be x equals h. Okay, why is it x equals? Because it's a vertical line. Vertical lines are always x equals. Okay, h. Have you learned a different way of finding axis of symmetry? And you better say yes if we did this last week. Or last Friday, the Friday before. What's your other formula for finding axis of symmetry? Opposite of b over 2a? Yeah. Okay, so you learned that one back in Algebra 1 and we reviewed it. Okay? So this is, if you're just looking at a standard quadratic, where it's not in vertex form yet, which if you're doing it this way, your vertex is that same number, and to find your y, you plug in the x value. Okay, what's a y-intercept? Where it crosses the y-axis. So, how do you find it? Just because I'm videotaping doesn't mean you can't answer questions. How do you find a y-intercept? Should be able to answer this question, it's not a hard one. Okay, so you have two options. You can put 0 in for x and solve. Okay, or the shortcut if you just have your, before you do vertex form, remember which letter it is? C, so it's either so like before I put this in vertex form, if I want to know my y-intercept of this, it'd be 6. Because if I put 0 in for x's, that's 0 and 0. It's going to be 6. If I put 0 in here and I solve, okay, 0 minus 2 1/2 is negative 2 1/2. Negative 2 1/2 squared, 6 1/4, minus 1/4 is 6. I get the same answer. Okay? What are your roots? Or solutions? Or zeros? What are those? Where the graph crosses where? X-axis. So you can look at your graph for those. We've done factoring. We've done completing the square. So either one of those, if you already have it like this, you could graph it and then just find them. Okay. Okay, what about your domain? What's domain mean?
All your x's.
Okay, so your x values. What do you know about quadratics and x values? Does every x value work or just some x values?
Some.
Some, you think some? Actually, they all work, okay? So your domain is actually all real numbers. Or double bar with R. I don't know how Ms. Draper showed you how to do this. Negative infinity to infinity. Those are all ways of showing all reals. Okay, what's range mean?
All your y values.
Your y values. Okay, now your y's are limited based on your graph. If your graph has a positive x squared, it's going to be all reals greater than or equal to whatever that value is, that y value. If it's a negative x squared and it goes down, it's going to be all reals less than or equal to this value. Okay, so that's my equation. Doesn't matter which one you use. Those are the exact same equation. What's my vertex going to be? Five halves and negative 1/4. okay? Now, the reason why, this is always minus in your formula, so you always change the sign when you take this out. Do you want to leave it as 5 halves, or do you want to put it as 2 1/2? What do you prefer? 5 halves, okay? So 5 halves, negative a fourth. Hey, if you want to find the vertex before you put in vertex form, you could do it the same way by doing the opposite of b over 2a. So the opposite of negative 5 was 5 over 2 times a. I get 5 over 2. Isn't that the same number I got here? Yeah, just a different way of doing it. Okay, what would my axis of symmetry be? Okay, what do I need to have in front of 5 halves? No, not negative. You need an x equals. Why do I need an x equals?
So then it shows that it's not like this.
Right, you have to show that it's a line. Okay, if I said 5 halves, that's just a number. Okay, x equals 5 halves, that's a line, and a vertical line. Okay, what about your y-intercept? We already talked about that. What's the y-intercept of this one? 6. So you can write 6. If it makes you feel better to put it as a point, the point would be 0, 6, right? Because you put 0 in for x's and solved. I'm not picky on this. Okay, have we found our roots yet? Have we graphed it yet? No? Have we found our domain yet? No, but what is our domain going to be? And we haven't graphed it. What did I tell you it
All
is?
real names.
It's all reals, because you have arrows going this way and you have arrow going this way. It's going to cover all of the x values. So, which way did she show you how to do it? All of the ways?
Yeah.
Oh, okay. Okay. And do we know our range? Technically we do, but have we graphed it yet? No. Okay. Now I know the range is going to be all reals greater than or equal to a 1/4. Okay? Or sorry, negative 1/4. But that's just because I know that it's the y value of the vertex. Okay, we haven't like talked about that yet. Okay, are we okay to graph? Do we remember how to graph? How do we graph? Where do we put, what did we do? On Monday? Or was it the Friday before? Okay, where we had the little like paper. Okay, so we have our vertex already. So where do we put our vertex at? Of our t-chart. Put it in the middle. So what is our vertex? 5 halves or 2 1/2? Negative 1/4. And then you want 2 or 3 numbers on each side, so I'm just going to go 3 numbers on each side. Now, I don't want to continue picking halves. Is that okay if we put it in like integers? So if I go smaller, then we do 2, 1, and 0. If I go bigger, that'd be 3, 4, and 5. Okay, now we already know what 0 is. What was 0? 6. We already found that. That was our y-intercept. Okay, when you're plugging the numbers into graph, you can plug them into your original equation for your x's. You have to do both x's. Or you could plug it into your vertex form. Do you have a preference? You want to do vertex? Okay. So if I plug in 1, 1 minus 2 1/2 is negative 1 1/2, right? Okay, negative 1 1/2 squared is 2 1/4 minus a fourth, 2. Now, if you plug that in up here, you're going to get the same answer. 1 squared is 1. 5 times 1 is 5. 1 minus 5 is negative 4. Plus 6 is 2. If you're not getting the same answer, that means you probably don't have it right in vertex form. Okay? Alright, so then if I plug in, what was next? 2? So 2 minus 2.5 is negative a half. Negative a half squared is a fourth, minus a fourth is 0. What's special about this numbers right here? What?
It's the same on both sides.
It is the same on both sides, but what's special about just this one?
Always your x-intercept.
Okay, it's your x-intercept, which is also your root or your solution. There's one of your solutions. It's one of the places it crosses the x-axis. Okay, so what do we know about these numbers right here? They're going to be the same as those. How do I know that? Because I picked them equidistant apart. If you're not equidistant, okay, it's not going to be the same number. So if you're not sure, why do you plug one of them in? Like I put in 3. 3 minus 2.5 is a half squared is a fourth, minus a fourth is 0. And this would give me 2, and this would give me 6. So Elijah, what would my roots be?
2 and 3.
2 and 3. Okay, why do I use solution sets? Because they're not points, right? They're just answers. Okay, so if I graph, so I have 0, 6, 1, 2, 2.5, negative 4, 3, 0. Oh, I forgot 2 0, sorry. 4, 2, 5, 6. Okay, and then this graph's going up. So my smallest y value is at my vertex, which was negative a fourth. So that means my range is all reals greater than or equal to negative a fourth. Or there's different ways you could write this. Like, I don't know if you did the such that, or if you do parentheses. Depends on how you want to write it. Okay, that's the whole shebang, I guess, for lack of a better word. That's all the properties of the graph. That's how you put it in vertex form, how you graph it. It's everything put all the way together. How do you feel about the graphing portion? Pretty good? You feel okay about like what these mean? As long as you know how to have it written down, you can go from there? Okay, so I feel like we probably just need to practice this part. Am I correct? Okay. Do you want to do another one that just has A as 1? Or do you want to go to ones that don't have A as 1? You feel okay about where A is 1?
Yeah.
So you might want to do another example. This is your chance. And don't feel bad if you ask, because I don't care. Okay. Okay, so this one's different, and I can't just divide by A, okay? Because I can't take y divided by 2. If y was 0, it wouldn't be that big of a deal, okay? But I have to keep everything on the same side. So what you're going to do is you're going to factor the 2 out. Now, you're just doing with this with the x squareds and the x's. Because if you were solving, that would be all that was on that same side. So this would be, if I take the 2 out, this would be x squared plus 4x. I do not take it out of the constant, just the x squared and the x part. And you don't take out an x, you just take out the a. Okay. After you do that, then we can put an adding one in the parentheses and a subtracting outside the parentheses. Okay, but here's what's special about a problem like this. If you factor out a number, whether it's a 2, a -1, any number, this blank right here has to get multiplied by that number you factored out. So this number right here, whatever it is, gets multiplied when you subtract it. And it has to do that because you have to balance out the equation. The 2 gets multiplied by this blank, so the 2 has to get multiplied by this one. That's the only difference between the first example and this example. Okay? So now we're going to take b over 2. So what's my v now? 4. So can I simplify 4 over 2 before I square it? 2. So what's 2 squared? 4. That goes in both blanks. Okay, everybody good? So then this would be y equals 2. Okay, so now my parentheses, I know it's x. That number right here is my b over 2, the number before you squared it. So plus 2. Okay, then on the outside, that 7 is still there. What's 4 times 2? So this is 7 minus 8, which would be -1. That's vertex 1. And you didn't have any fractions. What would my vertex be?
2,
Close.
-2, -1.
-2, -1. Because you have to change this sign right here, always. Do you want to do another one, or you feel okay? If you don't respond to me, I don't know how to answer that. Is it because I have a video going that you won't talk? Is it because it's